Hello, and welcome to our video about the binomial theorem. Today, we're going to be studying how to use the binomial theorem in Pascal's triangle to expand binomials. Remember, a binomial is just something like 2x plus 3. And we're going to use this to evaluate like 2x plus 3 to the 5th power. We used to have to multiply this out and write the binomials, and we had a lot of potential for errors. Now we can use this really cool trick and Pascal's triangle to help us out. But first we have to talk about what Pascal's triangle is. So this is a pretty interesting pattern. It happens a lot in nature, and a lot of people find it very interesting. So you start off with 1 and 1 and 1. And see how it makes a triangle, 1 and then 2. So then your next row will have 3. So you have a 1 on the outside and a 1 on the outside. To get this number in the middle, you just add. 1 plus 1 is 2. And then you have 1. And then to get this number, you add 1 and 2 to get 3. And then you have 3. And then 1. Each row will end in a 1. And then you will have 1, then 4, then 6, then 4, then 1. Then your next row would be 1, then 5, then 10, then 10 again, then 5, and then yet again a 1 on the end. Let's do a couple more. So then we have 1, add those two so we get 6, then we add these two to get 15, then 20, then we work our way back down. As you do this, you start to notice patterns. You kind of have a repeating pattern in every single row. You work your way up, and then you work your way back down. And the last one we'll do is 1, then we have 7, then we have 21, then we have 35, then 21 again. Oops, sorry, that's 35. 35 twice in this row. Then 21, then 7, then 1. So we can actually use this pattern to help us expand binomials. When expanding a binomial, the coefficients can be found by using the corresponding row of Pascal's triangle. Each row has a number. The perhaps tricky part is that the row on the top is row 0. Then the one with 2 ones is row 1. Then row 2, 3, 4, 5, 6, and 7. And again, this pattern continues on forever. So this number, the power that you are raising your binomial to, is the row that you look at. Keeping in mind the top row is 1 or is 0. So since this binomial is expanded by 7, that means we're going to the 7th row, which is the last row I have written down here in black. So what you're going to do is you are going to start by writing your coefficients and then writing an x and a y next to those coefficients. So I'm going to start with 1 and then plus 8xy. And so once you kind of write it all out, you end up like this. I initially said 8 here, that should be a 7. So these are all of your possible terms. So now we have to deal with the powers. So if you notice, each term has both an x and a y. Now you know that these are not all like terms, and the x's and y's as you progress are going to have different powers. So here's the trick. Start at the first one, start with this one, whatever one you have listed first, in this case the x. That takes on the 7. Both the x and the y, both terms have to have powers that add up to 7. So if the x has 7, then the y has to have 0. Then you decrease. So x has 6, which means y has 1, because that makes sense. X has 5, so y has 2. X has 4, so y has 3. This x here has 3, so this one has 4. 21x squared, y to the 5th, because that still makes 7. X to the 1st, y to the 6th, and then go to 0, y to the 7th. And that's your binomial, totally expanded. So you can simplify it a little bit and say x to the 7th plus 7x to the 6th y plus 21x to the 5th y squared plus 35x to the 4th y to the 3rd plus 35x to the 3rd y to the 4th plus 21x squared y to the 5th plus 7x y to the 6th plus y to the 7th. Now let's look at one where it's more than just a y. This one is x minus 4y to the 5th. So this time this 4 and this subtraction might trip us up a bit. So we just need to go slow and make sure we're being careful. So first we need to look at the 5th row of Pascal's triangle. So the 5th row of Pascal's triangle is right here. 1, 5, 10, 10, 5, 1. So I went ahead and wrote down the 5th row right here. So you have 1. And go ahead and write this and this, keeping the 4 negative. A lot of times it might help in this case to write it with parentheses. So you have 1 times x times negative 4y plus 5 times x times negative 4y. And so when you write it out, no powers yet, this is where we end up. So now let's start assigning our powers, remembering that 5 is the sum of both like the first term's powers and the second term's powers. The x and the negative 4y. So it starts off with 5 and 0, then we decrease. So 4 and 1, then 3 and 2, then 2 and 3, and 1 and 4, then 0 and 5. So this is where you just have to be very careful. So this first term, after we simplify, is x to the 5th. Then we have plus 5, x to the 4th, times negative 4y. So we can go ahead and multiply the 5 and the negative 4, which is going to be negative 20x to the 4th. Then we're plus 10x to the 3rd. Now we have negative 4y squared. And remember, when you square this, you're squaring both the 4 and the y. So negative 4y squared is 16y squared. So you're plus 160 x to the 3rd y squared for that term. So then looking at this term, we have to distribute the 3. So it's going to be plus 10x squared, and then negative 4 to the third power would be negative 60. Oops. And then y to the third. You have to cube both things. Which means when I simplify this, I multiply those two numbers, so this is going to be minus 640 x squared y to the third. Then, this next one, I have to do 5x, and then I have negative 4 to the fourth. Negative 4 to the fourth is going to be a positive, which is 256. And then 5 times 256 is 1280. X, y to the fourth. And then the last one, x to the 0 power is just 1. So I really just have to do negative 4 to the 5th power, which just ends up being negative 1024. And I need to bring down this x to the 5th. So this is your fully expanded binomial. Now, this rule might seem silly to know, but imagine if you had to multiply that whole thing out without using this trick. It would have taken you forever, and you probably would have messed up. So this rule is going to come in quite handy.